Hello, this is lesson 6.2. We're going to talk about describing functions. Okay, describing functions. Our standards today are going to be, I can investigate constant rates of change. I can describe and graph functions. I can determine whether a function is linear. And our standards would be 8F1 and 8F3. F1 is understand that a function is a rule that assigns to each input exactly one output. The graph of a function is the set of ordered pairs consisting of an input and the corresponding output. 8F3 interprets the equation y equals mx plus b as defining a linear function whose graph is a straight line. Give examples of functions that are not linear. I'm going to minimize myself. Constant rates of change. The U.S. Department of Agriculture defines heavy rain as rain that falls at a rate of 1.5 centimeters per hour. Fill in the chart below. So we have amount of rain that falls during rain periods. Let me just bring my annotation down here. So here's our input in hours, that's time. And total amount of rain in centimeters is our output. So if there's no time going by, there's no rain. If 1 hour of time goes by, how much rain will there be? We'll look back up in the word problem. You see it, 1.5 centimeters. So let's put that in our chart. Okay, what happens if there's 2 hours of time? How much rain will there be? 2 times 1.5 or 1.5 times 2. And that gives us 3 centimeters of rain. Okay, what if there is 3 hours of time? 1.5 centimeters times 3 hours equals 4.5 centimeters of rain. And we're just filling in the chart here. What if we do 1.5 centimeters times 4 hours? Then we get a total of 6 centimeters of rain. And finally, if we do 1.5 centimeters times 5 hours, we get 7.5 centimeters of rain. So we have just filled in our chart. How much rain will fall in 3.5 hours? That's right in between the 3 and the 5, right? 3 and the 4. 3.5 hours, you multiply 1.5 times 3.5 and you get 5.25 centimeters of rain. Okay, here's the same problem, but now let's plot the points from the table onto our graph. So the first point is 0, 0. There we go. 1, 1.5, 2, 3, 3, 4.5, 4, 6, and 5, 7.5. If you wanted, we could write the numbers here. We know that's 0, 0. This is 1, 1.5. It's supposed to be parenthesis. This point here is 2, 3, 2, 3. And this point would be 3, 4.5. etc. So you can figure out those points if you need to. Go back and take a look at that slide later because I am sharing the slides with you. Okay. There is the line that goes through those points. That is a linear relationship. Is the total amount of rain that falls a function of the number of hours that rain has been falling? Why or why not? I'm going to clear those points so we can take a look at it a little closer with the dots. Is that a function? Well, a function is defined as having exactly one output for each input. Do you see anywhere that the dots are on the same x value? that you would have a vertical line or vertical dots going up? No, right? So yes, this is a function because for any given input of time, there can be one and only one output of total amount of rain. So yes, this is a function. Okay, looking at the same chart and the graph that we've now drawn, this is also a linear function. There is exactly one value of y for each value of x. And you can see that it's y equals 1.5x. It's got a linear equation. And when we look at the graph, we can tell that it's a line. Criteria for a function. Okay, true or false? For a function to be a linear function, the relationship it represents must be proportional. What do you think? For a function to be a linear function, a line, does the relationship have to be proportional? False, right? The only requirement for the graph of a function is that the graph be a non-vertical line. Whether the graph passes through the origin, that makes it proportional, or not, that's non-proportional, that doesn't matter when you're determining if it's a function or not. Note that a vertical line has an infinite number of outputs for one input and goes completely against the definition of a function where there is exactly one output for each input. So for example, if this is your graph and it's a straight vertical line, actually let's undo that and make it a straight line. If this is your graph and this is your x value, let's say 3 on your graph. Let me just try to draw a brief graph here. I should really change the color so it's not confusing. Let's make this one blue. It won't let me. It won't let me. I'll make a different line. Okay, I'll make this one blue. That way, there. So there's our graph. That's the x value of 3. So for every 3, is there only one output? No, there is like a 1. There could be a 2. There is a 3. There is a 4. There is a 5, etc., and everything in between, right? Because you could have a point 3, comma 1. You could have a point 3, comma 2. You could have a point 3, comma 3, etc. So notice how there is many, many outputs for the number 3. So a vertical line goes against the definition of a function. You can only have one output value for the number 3, and that is not the case with a vertical line. Next question, true or false? All functions are linear. Is that true, or is it false? That's false. The only requirement for the graph of a function, again, is that the graph be a non-vertical line. Whether the graph passes through the origin or not does not matter. The function it doesn't have to be linear. It can just have only one input or output value for each input value. Okay. Let's talk about linear versus non-linear functions. The temperature at dawn was 8 degrees Fahrenheit and increased steadily 2 degrees every hour. The equation y equals 2x plus 8 gives the temperature y after x hours. State whether the relationship between the time and the temperature is proportional or non-proportional, linear or non-linear. This should be review for you guys. You should know where the slope is. You should know that 8 is the y-intercept, right? So is this a linear equation? Definitely. The equation is linear because it's written in the format that we're all very familiar with by now. Y equals mx plus b. So it is a linear function. The relationship between time and temperature is non-proportional because you have a B, 8. The graph starts at 8. It's 8 units above the origin. If you have a B, in our case an 8, a y-intercept other than 0, 0, it will be non-proportional. Okay. Now let's make a chart with our input and our output. So we're putting some x values here. We have our equation, y equals 2x plus 8. So we're putting the 2x plus 8 part here. We're just reversing it and putting the y on the right side. And then we're going to come up with an ordered pair. So if I plug 0 in for x, I get 2 times 0, or 0 plus 8. 0 plus 8 is 8. So y is 8. So my ordered pair then is 0, comma 8. X is 0, y is 8. There's my point. Let's plug in 2. 2 times 2 is 4. 4 plus 8 is, yes, 12. So what's our ordered pair? 2, comma 12. Let's plug in 4. 2 times 4 plus 8. That's 8 plus 8, 16. What's our ordered pair? 4, comma 16. What about plugging in 6? 2 times 6 plus 8. That's 12 plus 8. That should be 20. What's our ordered pair? 6, comma 20. See where those are coming from? Okay. Now let's graph our points. So we're going to graph 0, 8. We're going to graph 2, 12. We're going to graph 4, 16. And we're going to graph 6, 20. And then we're going to connect our dots. And notice how this graph does not go through the origin. We've already said it's non-proportional. It's 8 units above the origin. So that's because it's got the plus 8 in the equation. And there's our equation. Y equals 2x plus 8. That line has a slope of 2. It's the rate of change. And 8 is the y-intercept. Okay, it's your turn to try a couple of these problems. These should be fairly review for you. And then I'll see you back in a minute. Okay, welcome back. Hopefully you did those questions. Let's move on. Determining whether a function is linear. A square tile has a side length of x inches. The equation y equals x squared gives the area of the tile in square inches. Determine whether the relationship between x and y is linear, and if so, if it is proportional, and then is the relationship a function? Well, let's make a table. We're going to choose several values for the input x, and we're going to substitute those values into the equation to find the output y. So we're going to plug in 1, 2, 3, and 4. And this is our equation, just x squared is our equation. That'll give us a y value, right? Because y equals x squared. So if I plug in 1 squared, I plug in the 1 and then I square it. What is 1 times 1? 1, right? What's my ordered pair? 1, comma 1. Let's plug in 2 for x squared. So now I have 2 squared. What's 2 squared? 2 times 2, or 4. What's my ordered pair? 2, comma 4. Okay, let's plug in 3. So 3 squared, that's 3 times 3, that's 9. What's my ordered pair? 3, comma 9. Let's plug in 4. That makes it 4 squared. 4 times 4 is 16. What's my ordered pair? 4, comma 16. We have just made ourselves a table for this function. Okay, there's our table. I shrunk it up a little bit there so you can see all of our numbers. We have a graph. Let's plot all of our points. So we have 1, comma 1. Those are our points, by the way. So 1, comma 1, 2, comma 4, 3, 9, and 4, 16. Let's connect the dots. Okay, what do you notice? The graph is not linear. It curves, doesn't it? It doesn't have a constant slope. So it's nonlinear. And only a line can be proportional. So the graph is also not proportional. So if you don't have a line, it's automatically not proportional. Is this a function, and why or why not? Is there exactly one output value for each input value? Look at your graph. Do you see more than one dot above the 1? Do you see more than one dot above the 2? Do you see more than one dot above the 3, the 4, or the 5, etc.? No, you do not. So yes, this is a function because there is only one output value for a given input value. Notice how even though it's not a line, it's still a function. Linear, proportional, and function tests. Okay, now keep track of this here. Okay, a linear test, and we talked about this in a previous video. In a table, the linear test to tell if it's linear is to find the change in y over the change in x for each point in the table. And if that is constant, that's y2 minus y1 over x2 minus x1. If that's constant, then it's a line. In a graph, the test is, well, you look at the graph. If it's a straight line, then it's a linear function. In an equation, the equation will be arranged in the format y equals mx plus b, or you have to use algebra to arrange it in that format with y on one side and the rest of the equation on the other side. That's your linear test for a table, a graph, and an equation. What is the proportional test? Well, in a table, y divided by x is constant for every point in the table. If it's in a graph, we know the proportional test really well for that, right? The graph will go through 0, 0. And finally, in an equation, if the equation does not have a b, then it is proportional. In the y equals mx plus b format, there'll be no b because the point would be 0, 0. And finally, the function test. To determine if a table is a function, there must be a different x value input for the entire column. Okay, if you have x repeating, 2 points, 2 numbers repeating in the x column, it's not a function. How do you tell if it's a function in a graph? Well, you look, there should only be 1 point on the graph for a given x value. There should never be a vertical line of dots going up. And in an equation, the function test is you have to rearrange the equation so that y is on one side of the equation. If y equals some rule, then it is a function. If y squared equals some rule, then it is not a function because there can be 2 values for y, because y squared could be a negative and a positive to give you the same number, right? Okay, now you're going to get to try a whole bunch of problems to determine if it's a function, if it's linear, or if it's proportional. Okay, welcome back. Hopefully you did all those questions so they're fresh in your mind. And now let's talk a little bit about some higher order thinking. Okay, show that the equation y plus 3 equals 3 times the quantity 2x plus 1 is linear, proportional, and a function. So you could have an equation like this. You have to use algebra to rearrange. So rearrange the equation so that y is on one side of the equation all by itself. So there's our equation. How are we going to get y by itself? Well, we have to do a number of things. First, we have to use the distributive property. I don't know if you remember what that was. We talked about that a lot in 7th grade, and we've talked about it some in 8th grade. So you have to multiply the 3 in front of the parentheses times each number in the parentheses. So 3 times 2x and then 3 times 1. When you do that, 3 times 2x is 6x and 3 times 1 is 3. So now we have y plus 3 equals 6x plus 3. Remember, our goal is to get y by itself. So we're going to subtract 3 from this side and from that side. When we do that, we get y plus 0 equals 6x plus 0. Now we have to get y by itself, and we have it, right? Because 0 just crosses off. So we have y equals 6x. We have just rearranged our equation so that y is on one side, and now we can determine that it's linear, proportional, and a function. How do we know that? Well, since this equation is now in the format of y equals mx plus b, even though we have no b because it's not in this case, it's a 0, right? We can see that it is linear. It is also proportional because we have no b. There is a 0, 0 point. And finally, it's a function because no matter what input value is put in, it will always be multiplied by 6. So there will always be exactly one output value, one different output value, y, for each input. So this relationship is a function. Okay, your homework is on Google Classroom. I'll come back and I will see you next time. Bye.